Hello everyone. So today we are going to discuss CodeChef Starters 218. We are going to solve all the problems. Let's wait for 2-3 minutes for everyone to connect. Okay, only one viewer is there. We will start in 2-3 minutes. So just wait. Okay. So let's start. So this was the first problem. It's not rated in, but still we are going to discuss all these. Okay, so in this problem, you are given with chef opened a tree selling business in Christmas. He bought N trees for A rupees and sold M trees for B rupees. What was his profit this Christmas if chef instead made a loss of X rupees? Print negative X. Okay, just right. So the first problem, it's saying that your cost price you have bought n items for a rupees. So the total cost price is n into a, and then you say your selling price is you have sold m items for b rupees. So your selling price will be m into b. Now your profit or loss is just m, or I can say selling price minus cost price, or you can say m into b minus n into a. Okay, so this was the problem. As you can see, for the code, I have just taken the input and output the m into b minus n into a. So this was the first problem. Let's move to the second problem. Okay, this is the second problem. In this problem, it is stating that there are n different colors of balloon numbered from 1 to n, and the ith color balloon cost exactly I. That is, the balloon of color 1 cost 1 rupee, balloon of color 2 cost 2 rupees, and so on. You bought AI balloons of the ith color. What is the total cost of the balloon you bought? Okay. So in this particular problem, it is given that you have an array. Just give me. In this, you are given with an array, say A1, A2, A3, and A4. And for A1 uh, or A1 balloons, you buy them for 1 rupee. For A2 balloons, you buy them for 2 rupee. For A3 balloon, you buy them for 3 rupee. And for A4 balloon, you buy them for 4 rupee. So what will be the total cost of the balloons you spent? How much you spent? it is just a1 into 1 plus a2 into 2 plus a3 into 3 plus a4 into 4. You can just take in a counter as start from 1 and keep incremented it and multiply them with the array elements. So as you can see in the code, I have taken input as n. I have made my answer as starting with 0 and I made a counter starting from 1. Then I have iterated over the n. Then I have taken each integer x as its input and I added x into count in my answer and then post incremented. Then you can just output the answer. Okay, so this was the second problem. Now let's move to the first problem of division 2. Okay, so in this particular problem, you are given with Chef is participating in an election going up against his enemy anti-Chef. There were n voters and their votes are described by a binary string s where si is equals to 1 if and only if the ith voter voted for Chef. The votes will be counted one by one in the order 1 to n. At any point, Chef can say to stop the count and the remaining vote will not be counted. Chef want to win, and how many ways are there for Chef to win depending on whether he says to stop the count. Two ways are said to be distinct if there are some voters whose vote got counted in the first way but not in the second way. Note that a tie is not a win for Chef, and Chef can also say stop after the count of all n votes. Okay, so let's take an example 10011. So in this problem, it is saying that you are given with a string which is in binary. If si is 1, then voter voted Chef. If si is equals to 0, then a voter voted anti-Chef. So tell me, in what conditions Chef will win? What are the conditions Chef will win? Chef can win if count of 1 is greater than count of 0. So what we can do? Let's say this is the string. Now we can choose 1 to stop. In this particular stop, the count of 1 is 1 and count of 0 is 0. So Chef will win. So this is the first win for Chef. Now if you say stop here, the count of 1 is 1 and the count of 0 is again 1. So it is a tie. So Chef doesn't win. If you go here, the count of 1 is 1 and the count of 0 is 2. So Chef again, in this case, Chef lost. So bro code chef better a देखा थे. I don't understand what do you mean. Okay, so uh, in this particular case, count of 0 is 2 and count of 1 is 1. So Chef lost. In this particular case, if you stop here, the count of 1 is 2 and count of 0 is 2. So it is a draw. So again, no win. In this case, the count of 1 is 3 and count of 0 is 2. So in this case, Chef wins. So my total wins are 2. So there are two distinct ways to win. Right? So if we look at the code, you just what you have to do, you just iterate over the string, count each count of 1, increment count of 1 if Si is 1, increment count of 0 if Si is 0. Then check if C1 count of 1 is greater than count of 0, you just increment your answer. So this is the logic for this code. As you can see, what I've done, I have taken test cases as input, then I have taken n as input, the string, and I have made two variables v1 and v2 for vote 1 and vote 2, and a total wins answer. I have iterated over the string. If the string contains 1, then I will increase vote 1, else I will increase vote 2. If vote 1 is greater than vote 2, then I can increment my answer, which means chef win. And you can just output your answer. Okay. So moving to the next problem. Yeah. Deleting array again. So you had an array of size n and a cost array c of size n. You will do the exactly n operation of the following types. Choose index I, that is I is in the range of 1 to n. Modulus A is just size of array, and then delete AI from the array. The associated cost of this operation is AI into CI. Bro, which is better, CodeChef or LeetCode? Both are better. Like CodeChef is better because it has more mathematical part. LeetCode has more standard problems. That's why. If you need to focus on your mathematics or problem solving, you can just do CodeChef, and if you want to do standard DSA for interviews, you can do LeetCode. The associated cost of this operation is AI into CI, and after the operation, the remaining part of A are concatenated and the re-index from 1 to A. Note this that the array C is not modified. Find the minimum total cost need to perform on n operations. After n operation, we will delete the whole array. We need to find the minimum cost. Okay. So you are given with an array A and an array C. Now you can delete any index. Let's say I deleted A3. Let's decrease the size so that you can understand. Okay, so size is A5 and E6, C5 and C6. Now, if I delete element E3, then my current cost is A3 into C3, corresponding element, right? Now, after deleting this element, all these uh, remaining element behind A3 will shift one by one. So the new array will look like E1, A2, A4, A5, and A6. Then C1, C2, C3, C4, C5, and C6. Right? So if you again delete some element, let's say you deleted A5 this time. So your cost will add up to A5 into, you will not multiply C5 this time, you will multiply A4, the corresponding element. So you multiply C4, right? So after deletion, the array will look like A1, A2, A4, A6, C1, C2, C3, C4, C5, and C6. Now you can delete any element. Let's say I deleted A1, then the corresponding cost is C1, A1 into C1. Then array will look like A2, A4, and A6, C1, C2, C3, C4, C5, C6. Then you can delete A4. The cost will add up to A4 into C2, then array will become A2, A6, C1, C2, C3, C4, C5, C6. Then you can delete A2 into C1. Then last element will be A6 and the corresponding will be C1 again. So and this will cost A6 into C1. So the total cost will look like this in this format. So you need to minimize this total cost. Now I need to tell you one thing. Say our array is like this and C array is like this. And I tell you that C2 is the minimum element of this whole C. And so you will try to multiply all the element with C2. Yes or not? You cannot multiply A1 with C2 because it is on the left side of C2. That's why. But you can multiply A3 with C2. How? You can first remove A2, then you can multiply A3 with C2. You can multiply A5 with C2 also. You can just remove A2, then A3, then A4, then A5. Right? So you can choose a minimum index up to that particular index. Then you can choose which element to multiply with which C, with cost. Say you can you have array 5 and you want to multiply it with the minimum element. So you can choose to take any element which is less than equals to 5. So 1, 2, 3, 4, 5. All these indices can be true for A5. For A3, you can again choose the minimum element, but in this case, 1, 2, and 3. Only these three elements you can take. These three indexes you can take. Same goes for A1, you can only take one. So I think you understand the pattern in this problem. So what you gotta do, you will iterate from 1 to n. Then you will make a minimum value and you will always take minimum with ci, current ci, and then multiply our element with that ci. So this greedily will give us the minimum cost. I guess you understand this part, how I am doing minimum value by taking the minimum of current ci with the min value, and you can just multiply with the min value. This will always give the minimum cost. We can iterate, we can do a dry run on an example. 1 10 4 7 5 3. So right now, rather than multiplying 1 with 7, 1 with 5, 1 with 3, I can choose to multiply 1 with 4 because it is the minimum in this range. I can again choose to multiply this one with 4 because it's still minimum in this range. So I can choose because this is fixed. I cannot choose for this. So I will take 1 into 10 plus 1 into 4. Then I can choose to multiply this one again with the 4. So I can multiply this. Then I can again choose to multiply this one with the 4. 1 into 4. Now I can delete this with the same value. So I can take 1 into 3. So the flow will be look like, first let me just erase this. So the flow will look like I have first deleted this element, then I got the cost of 3 plus, then I have deleted this element, I got a cost of 4, then these will shift here, then I again delete this element which is shifted here, so the cost is 4, then this will again shift here. So if I delete this element, it will again give me a cost of 4. Then I can delete this element which give me a cost of 10. So the total cost is 8, 7, 15, and 25. Right. So the total cost will be 25 for this example. Right. So let's look into the code. As you can see, I have taken n and arrays and as input a and c. I have made a total cost and I have taken a minimum c value currently with the infinity. Then I have iterated over all the n and I have taken minimum of ci with that particular min c value. Then I have added the total sum as ai into min c. Then you can get the total answer. Okay, is this clear? Okay, if it is clear, then we can move to next problem. All right. So next problem is counting optimal arrays. Okay. So in this problem, you are given with for an array a of size n, define fa as summation of from 1 to n minus 1 ai's or ai plus 1 which means a1s or a2 plus a2s or a3 dot 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 an's minus 1s or an. Here XOR represent the bitwise XOR operation and fa is defined as 0 for n is equals to 1. Given a integer n and m, consider the arrays a satisfying the length of a is n and all the values of ai is less than equals to m. Let s denote the maximum possible value of fa. And we need to find the number of arrays a satisfying the constraint such that fa is equals to s. And we need to do the modulus with 998 244 353. Okay. So what the question is stating, mm, this is I guess. So what the question is stating is you are given with fa as summation of I is equals to 1 to n minus 1 ai XOR with ai plus 1. So if you open this value, it will look like a1 XOR a2 plus a2 XOR a3 plus a3 XOR with a4 up to an minus 1 XOR an, right? And if you need to first maximize this value, and that value is s. So after maximizing this value, you need to find the count of all arrays with f of arr as s. Okay, so how many of you have solved this problem? What are the approaches you have taken? This was quite a typical problem. Then the next one, which was conjure, I guess that was the name, conjecture, easy. That was an easy problem, but this was is quite tricky. You need to know bitwise operations and you need to know about bits. How many of you have solved this and what are the approaches you have taken? Mm, Anyone? Okay, so no one is answering. I can just continue now. So I need to maximize AI XOR with AI plus 1. I need to maximize this thing. So how can, when two values are XORed, what is the maximum value? How can I obtain this maximum value? Anyone can tell? If I am XORing X and Y, I need to find a maximum value. What will it be? It will be, I guess you know it is always that if bit is set in X, then it should be unset in Y and vice versa, right? So, for example, mm, this is my X. So, what is the Y that maximizes with X or Y? The Y will be, if this is 1, I will take 0. If this is 0, I will take 1. If this is 0, 1, 0, 0, and 1. So, this Y will maximize X or Y, right? And there is a trick also that the maximum X or Y is always X plus Y, right? The maximum X or Y is always X plus Y. So you can use that trick also, but here what I am going to tell you. So I need to set X and the consecutive elements in such a way that if a single bit is, I need to set consecutive elements such that if a bit is set in 1, it is unset in second, right? So let's take an example. M is equals to 6. So 6 can be represented as 110. So 6 can be represented as 110. I can take this bit as set and these are unset. So the x will be this and y will be this. So I can write it as 6 and 1. So one of the array will look like 6, 1, 6, 1. Oh, sorry, 6, 1, and so on. Or you can write it as 6, 1, 6, 1, 6, 1, 6, so on. As you can see, these both are giving maximum or as 7. These both are given as maximums or 7. These both, these both, these both. So I will always get the maximums out of, and the sum will be maximum. Fi will be maximum. Same for this, as you can see. All these zorts will give 7, right? Now, are there multiple values of x and y possible for this particular combination? Yeah, there are multiple values. For example, x is equals to 3, y is equals to 4. 3 can be represented as 0, 1, 1, and 4 can be represented as 1, 0, 0. Then the array will be looking like 3, 4, 3, 4, 3, 4, so on, or 4, 3, 4, 3, 4, 3, so on. As you can see, these both when XORed will give 7. These both will when XORed give 7. Look, the XOR is always 7 and the sum will be S for these array. They will be S at every single time. Now, is there any other value of xy which gives us the same result? It can be. There it will be 2 and y equals to 5. As you can see, the x plus y rule follows x plus y 6 plus 1 7, 3 plus 4 7, 2 plus 5 7, right? So it can be written as 0 1 0 and it can be written as 1 0 1. So as you can see, the array will look like 2 5 2 5 2 5 or 5 2 5 2, so on. And all these XORs will give 7 again, right? So after this, what I got one thing, that my pad there is a for each xy there are two patterns, which is x y x y or uh, y x y x. Now I just need to calculate a particular x and y each time and multiply it with 2 because there are two arrays that satisfy one xy. So my problem is now to find all the xy's and then multiply it with 2. Okay, you cannot run over n. Can you tell me why? You cannot do a loop for x 1 to m and find y. Why you can't do this? Because the constraint m is 10 raised to power 8, and if you do m by 2, which is suitable, it will still be a 10 raised to power 7, and 5 into 10 raised to power 7, it will give TLE. So you cannot run a particular loop in this scenario. What you can do is you can uh, change the approach in the binary representation of a number. Look, I know that if m is 6, then I can find the first pair of numbers xy. X is equals to 6 and y is equals to 1 by changing the bits in 6, right? I can find the first pair. Now, if m is 6, let's say 110, right? What I need to do is I know that this bit will be fixed if if the number uh, if the number is maximum. I'm talking about XOR of AI. XOR is AI plus 1. If this is maximum, this one bit is fixed in all the scenarios. As you can see, for 4 it was fixed and for 5 it was fixed. As you can see, these bit can change accordingly. This bit can change, right? Okay, so if I say my number look like this, start with 1 and all these values are n, can be anything, I don't know. I need to find the number of x y's, so these can be anything. If I ask you if this particular bit is 1, then how many possible combinations of xy can be possible? You can put a 0 1 here, a 0 1 here, a 0 1 here. So there are 2 raised to power k operations or 2 raised to power 3 operation, right? If this bit is set 1, if this bit is unset as 0, Is this true? Can I take a bit which is unset and calculate how many pairs it is giving me? Is this true? No, it's not true because the bit is unset in this case. And when I was taking XOR, you can see 7 was coming, which has all the bit as on. And you will always take a XOR which has all the bit on. So if one bit is off, then the answer will be false. The answer will not be true. So what my algorithm will look like, what I'm going to do, I will iterate from the most significant bit -1 to the least significant bit. And this most significant bit is currently 1 here. So I will iterate from here and go up to the last point. And I will just multiply if bit is set. If bit is set, I will just add 2 into 2 raised to power k in my answer. Why this 2? Because there are two patterns as I just discussed. Like I just said na, XY and YXYX. So there are two types of pattern and there are 2 raised to power k possible combinations. So I will just add 2 into 2 raised to power k in my answer. Now, if you are left with you in the end, you will just add 2 again because there are two starting positions 6161 and 1616, and then you can just return your answer. What you are saying by P2, I mean the smallest power of 2 that is strictly greater than m. I think the message you have sent is not visible in the live chat. Can you send it again, please? Prabhuth Goyal. Can you please send the message again because I can't see the message. Okay, so if we look at the code, I'm sorry. If we look at the code, as you can see, I've taken n and m as input. If n is 1, then answer is always n plus 1. This much you can decode like if n is 1, then we are told that f of n, f of arr will always be 0. So you can take any element from 0 to m, right? Which are 0, 1, 2, 3, 4 to m, and these are m plus 1 elements. So output is m plus 1. If m is 0, then answer is just 1 because you can output only one style of array, which is 0 by p2. I don't know, your chat was visible and then it got deleted. Yeah. So as you can see, if n is 1, output is m minus 1. If m is 0, then there is only one possible combination of arrays, that is 0, 0, 0. Then here I have taken the leftmost bit, most significant bit. Starting with -1, I have iterated from 30 to 0. And whichever bit is on, I will just update that leftmost bit is I and break. Now this answer contain all the possible combination of arrays. Then I have taken path as 2 because there are two types of path. As you can see, as I have told, XY or YXYX. Then you iterate from the least significant bit -1 from the to the end and check. This is I have taken out the bit which is in the m, and if that bit is set, I will take ways as path multiply by 2 raised to power k and just add your base into the answer. By P2, I mean the smallest power of 2 that is strictly greater than n. Uh, Smallest power 2 that is strictly greater than m. Where? Think. I don't know which part you are telling about. Okay. So after that, you can just add the total number of base and you can increment your answer by 2 and this output your answer. Is this clear? Any doubt in this particular problem? I guess no. Okay, so we are moving forward to next problem. This one was particularly easy than the previous one. In this problem, you are given an integer n. You can do the following operations. If n is even, choose to change n to either 3's or n plus 1 or n by 2. If n is odd, you can change n to 3's or n plus 1. Here OR defines the bitwise OR operation. Check if it is possible to go from n to 1. Print yes if it is possible, else no. So this was an ad hoc problem. You want to go from n to 1. If n is even, you do n divided by 2 or 3 XOR n plus 1. If n is odd, you do 3 XOR n plus 1. Okay, so uh, in these particular type of problems, you can do multiple things. For example, I can just write from 1 to say 15 or 20 and just check the answer for each. Let's do it. I'm going up to 10, 6, 7, 8, 9, 10. Right. Now, 1 is already 1, so it gives us yes. 2 can be changed into 1 by 2 divided by 2, so it's still yes. 3, we can do 3 XOR with 3 plus 1, it will give us 1, so again yes. 4, we can do 4 divided by 2, then 2 divided by 2, then 1, still yes. Now for 5, you cannot reach uh, 5 to 0 in any case because it is visible in the example also, as you can see. From 5 you cannot reach, so answer is for 6 you can do 6 divided by 2, it gives us 3 and 3 is already true, so yes. From 7 you cannot reach, again no. From 8 you can reach as 8 divided by 2, then 4 divided by 2, then 2 divided by 2, yes. From 9 you can't reach, and from 10 you also can't reach. So if you look at these test cases, you can formulate or you can extend it. It gives us no. For 12, it gives us yes, as 12 divided by 2 gives us 6, and 6 is visited. 6 is marked as 2. So, yes. So, if you look at the pattern behind this, you can see all the odd elements greater than 3 are no. Okay, why 10 is no? 8, 12, 4 is true, 6 is also true, but 10 is no. So elements which are divisible by 4 is true, because 4, 8 and 12 are true, right? Else you can do no. And what are the brute cases? These are 1, 2, 3, 6 and n modulus 4. So these are the brute cases that gives you yes, else all other will go no. Okay, so this can be one potential approach you can use for ad hoc type problems and or pattern recognition problems. Rather than I will always also explain you the mathematical part of this question. So we are given with two types of operation. One operation is n by 2, which divides or right shift. The other operation is 3 XOR n plus 1. Now what this operation do? Can anyone tell? 3 is represented as 0, 0, 1, 1. There can be multiple zeros. The last two bits are on, which means it will flip the bits in n. It will flip last two bits in n. Okay. So what does this flipping means? Say if n is divisible by 4, which we have taken, so last two bit will be 0, 0, correct? And it will flip the bits, so 0, 0 will be converted into 1, 1. I think you are sure about that. If n is 4, then last two bit will be 0. 4 is represented as 1, 0, 0. 8 this 12. So as you can see, last two bit are always 0. Okay, so this will convert it into double 1, and when you add 1 to it, then the total addition is from 0, 0 you go to double 1, which is total addition of 3, and then you added 1, so total addition of 4. So 3 XOR n plus 1 can be written as n plus 4 directly. So there are only two kind of operation. One you are doing n divided by 2, and the second one is you are doing n plus 4. So it is clear that you cannot reach from odd to 1, any odd to 1. You can't reach. 3 is an exception, because if n is 3, when you XOR 3 and 3, it will give us 0, and while adding 1, you get directly 1. So any odd residing 3 will never reach to 1. Okay. So this gives us one thing, that if n is odd, we are giving no, and if n is even, as you can see, we are adding 4 all the time, and we can only divide it by 2. So it should be either 2 raised to power n, or it should be either n plus 4, right? We can do n plus 4, correct? So this defines as if n is even, it should either be 2 raised to power n or 2 raised to power k. N is already defined, so 2 raised to power k, or it should be modulus by 4 to give it a 0, right? 6 is exception again, because for 6 you can just directly convert it into uh, 3 by dividing 2, and 3 with 3's or n plus 1, p plus 1. Now one more thing is there, because 3 is giving us the right answer. Anything which is in the form 3 into 2 raised to power k is also giving us the right answer. Okay, because 24 can be converted into 1. How? We can do 2 24 12 divided by 2. Oh, sorry, divide by 2 gives us 12. Then divide by 2 again gives us 6. Divide by 2 again gives us 3. And then 3 can be converted into 1. One output 1. 2. Find this smallest period of 2 greater than. Compute answer is 2n minus p raised to power 2 plus 2. Yeah, that's what I'm doing. Like, you have to do a 2 raised to power k, which are the bits that are set in that particular problem. After m, for m, if it is 1, it is on, then you can just take all these bits which are remaining and take the 2 raised to power k of those bits and multiply by 2 and add it to some add it to your answer. The same thing you are doing 2 into m minus p2 plus 2. So it's the same thing you can do directly also. But I am trying to explain the reason behind the particular problem, why you are taking that bit. So please look at this also, because this will be used in the second part, hard version. I just wrote a brute force and just noted the pattern. Yeah, if you write the brute force, and you can just note the pattern for this particular problem. Okay, so 3 into 2 raised to the power k can be also converted into 1, correct? 20 can also be converted into 1, as you can do 20 plus 4, it will give us 24, and you can just follow this pattern again. So you can always get into 1 if n is divisible by 4, and n is 1, n is 2, n is 3, and n is 6 are root examples, because after that any element that will come, which will it will cover by this. So if you look at this particular solution, what I have done, I have just taken the input and check for n equals to 2, 3, 4, 1, 2, 3, 6, and n divisible by 4. If it is true, then answer is yes. As you, if 2d, okay, diff 2d, yeah, we are going, we are at d on, I guess, yeah, it's a d, yeah. Okay, so then this was the problem for this. Now coming to the hard version of this particular problem. How many of you saw this particular hard version? What are the approaches you have thought, or what are the ideas you were able to come up? You can write in the chat, I will read. Okay, so it is, I guess, G. Okay. So continuing in this part, now you are asked to print the minimum number of operations also. Okay, for yes, you need minimum number of operation, and for no, you have to print -1. Okay, now it is updated. How can you do that? C++, yeah, we are doing in C++. Okay, how you can solve to find the minimum number of operations? As I have just told you about that, if n modulus by 4 is true, we can put a base cases like if n is 1, then answer is 0. If n is 2, then answer is 1. N is 3, answer is again 1. And n is 6, answer is 2. 6 divided by 2 and then 3. Okay, so I am putting these as base cases or brute cases. So what is the last thing that is remaining to me? First is if n modulus 4 is not is equals to 0, or n modulus 2 is 1, which means it is not divisible by 4 or odd. In both of these test cases, I will output -1. So this is clear. These base cases are clear. Now what is left for me for this particular problem? I have to check for n modulus 4, which are true, and I have to find the minimum number of operation for these. How can you do this? Look, I'm going to explain you a particular thing which I was not able to come up properly during the contest. I have read a really typical code, but you can do it in an easier way. Look, we can only divide by 2 or do n plus 4. So these are the only operation I have. So if I have only two kind of operations, which algorithm we should use? Yes, Kabir, please ask. There is a algorithm BFS which you can use to find the minimum path, as you can make a node like these. Start with n by 2, then n by n plus 4, then n by 2 by 2, then n by 2 plus 4, n by n plus 4 by 2, and n plus 4 by n plus 4 plus 4. So you can run a BFS also, but it will give TLE as n is 115. So total number of combination pairs are, if 115 can be represented at 2 raised to power 50, so there are 2 raised to power 50 combinations of 50 length of nodes and 2 raised to power 50 combinations. So it will give us TLE. Yeah. So BFS won't work in this particular scenario. So there is a algorithm which you have heard about, which is called reverse engineering. We will use this. How? As I know that n by 2 can convert any bit to it can reduce one bit, right? So if the bit set is like this, I can reduce one bit by n by 2 or dividing by 2, correct? So any number can be converted into one which is in the form 2, 4, 8, 16, 32, and so on, correct? So I can use this particular operation to make 8 into 1 in 3 operations, because logarithmic of 8 is 3, logarithmic of 16 is 4, and so on. correct? Now, what I'm going to do, I will take element t as the power of 2 raised to power k, which is just larger than n. So I will try to make n into t by doing our division operation, or I am doing that n plus 4 operation. Okay, let's understand this with an example. N is 20 currently, and I have to take it to 1, right? What will be my t? T will be power of 2 just larger than n, so it will be 32. It will be 32, right? Now, if you look at the bit set of both of these, 20 can be represented as this, and 32 can be represented as this. Now, see the fourth position. They differ, right? So I will try to make both the bits same. How can I do that? I will update 20 plus 2. So I will do 20 plus 4. It will turn into 24. So now this bit will be converted into 0, and this will be converted into 1, right? Now if they are converted, I can remove all these bits, same bits. How I will remove them? I will just do division operation, like 24 and t is 32. So I will do division operation. It will go to divide by 2. Sorry, just, just give me a second. You cannot remove all these bits. You can, let me show you. When you do a division operation to remove one bit, it will be converted into 12 and it will be converted into 16. Now these bit will be shift. Now fourth position of bit is again differing with by 1 and 0. So I will again do 12 plus 16, 12 plus 4, which give me 16. And then t is again 16, as you can see. Now both n and t are same. Then I can just do n divided by 2. So it will become 8 and 8. It will become 4 and 4. Then it will become 2 and 2, and then 1 and 1. So how many operation I have taken for this? I have took one operation for converting 20 to 4, then to second operation 24 by 2, then third operation, fourth, fifth, sixth, and seventh. So it was a 7 operation step to make it 20 to 1. But can we do it better? I have just told you there is one more way if it is in the form of 3 into 2 raised to power k. So I can try to convert 20 into this form also. How can I convert it? If I do 20 plus 4, it will convert it into 24. Now look at this. 24 can be represented as 3 into 2 raised to power 3. Right? So I can just directly divide it by 2, give us 12 divided by 2, give us 6 divided by 2, give us 3, and then directly 1. So count the number of steps here. 1, 2, 3, 4, then 5. The total number of steps are 5. Which is the minimum? 5 is the minimum. So in this particular scenario, we have to take care of two things. We can either choose to convert into power of 2, or we can choose to convert into 3 into 2 raised to power k. So we will be doing this two operations simultaneously. Right. So let's look at the code. So as you can see, I've taken test case as input, n is input. If n is not even, if n is 1, then output 0. If n is 3, output 1. Else, for all even, all odd, you can output -1. If n is 2, then output is 1. Then if n is 6, output is 2. If n modulus 4 is not equal to 0, for all elements which are not divisible by 4, I will output -1. Now, answer is 2 raised to power 80, which means my currently operation number of operations are 2 raised to power 80. Let's come to this particular function later. Now, I have taken P2 as the power of 2. I need to find the power of 2 which is just greater than n. So I have done a while loop in which if P2 is less than n, I will multiply P2 by 2 and it will give me a power of 2 which is just above the question. Here, most of us not aware about your question. Mukesh, did you not understood the problem? Uh, I can explain again if all of you are not able to understand it. You can answer in the chat. If everything is clear, I can move forward. Uh, I think Mukesh is telling about Kabir's question. So, as you can see, what I have done, I have iterated 3 times, iterated 2 times, sorry, 0, 1, and 2, 2, 2, and I have just taken answer as minimum of answer and calculated with n comma p2. Right? I have run this loop 3 times. Right? So, for the proximity, if the answer is correct or not, then if answer is infinity, then I can just break and multiply p2 as 2. I have increases my search space for the p2. Like 32 is not satisfying my 20, then I increase to 64. I can go up to 64. If 64 still can satisfy, I will go up to 128, and this is the maximum that you can go, because beyond that it will always satisfy. Right? Then I have taken a p3 as 3 and do the same. It what is doing? It is just taking 3 into 2 raised to power k. So it is in this form. Alright. Kabir, I don't know about that prime batch of AIML from your whatever institute. So please don't spam in the chat. Okay. So I have taken P3 as 3 and represented P3 in this form. 3 into 2 raised to power k, which is just larger than n. Then again, 3 times I have taken the loop, because in this particular 3 loop, you can get the answer. Then I have taken again answer as the minimum and calculated with n comma p3. If it is infinity, I will break and multiply p3 as multiply by 2 and increase your again value by if it is 24, then multiply by 2, 48, 48, then again 96, because you will get an answer at certain point. If it is still infinity, answer is still infinity, you just output -1, yet you cannot reach the particular element, else you can output answer. Now, if you look at the function, in this function, what I'm doing, I have just told you what I'm doing. I will first try to make for P2, I will try to make bit same in the fourth position, and then I will right shift all this or divide by 2 or the n and t. So My current is n, and my destination is the target, which is t. Now, if target is less than current, you can just return infinity. If distance minus target is divisible power is not equals to 0, which means you can never reach your distance or your target, you just output infinity again. Now, the number of operations, number of shifts which you have done, right shift or division operations, temporary n and temporary t. While temporary n is less than temporary t, I have taken check the both the bits of n and t at that fourth position if they are set, or if they are same or not same. If they are not same, what I will do, I will just update my n by plus 4 and update total number of operations by 1. Then you can just divide both of them, which I have done in this, sorry, which I have done here. If the bits are not same in this fourth position, you just add 4 and then divide it by 2, right? And you will keep doing this until your number will become same, right? As your number will become same, the file loop will break. And if any certain point they don't become same, you can just output infinity again. And you can also check if number is a power of 2 after doing these operations. If it becomes the power of 2, you can just take the answer directly by dividing it. Temporary n is greater than 1, just divide it and increase your remainder, or do the number of operations. Then the operations will be operation plus shift plus remainder, the number of divisions plus operations which you have done plus 4, and the remaining, which means your last divisions of 2. Now, in this else part, in this particular part, what I am doing the 3 into 2 raised to power k thing. If n is divisible by 3, I will divide it by 3 first, then check if it is in the form of 2 raised to power k, then I will just again do the same thing, operation plus shift plus remainder, and this one is for division of 3, which I have done here in the line 65. And still you can't get the answer, you can just return an infinity. Okay, so that was the code for this particular problem. Do you have any doubt or anything which is not clear? If it is, we can move to the next problem and the last problem of today's contest. Okay, right. In this particular problem, you are given with, for an array A of size n, we define FA in the following ways. We start with the score 0 and your hand is empty, right? And for each day I from 1 to n, repeat this following step in this order. If your hand is empty, you may choose to pick up the current items. It worth AI and you may choose not to. If your hand contains an item, you may choose to sell the item and it will worth the total score, worth to the score. Or you again choose may not to. If your hand does not contain an item, if your hand contains an item till now and it item worth is increases by 1 due to interest, your hand should be empty at the end of n steps. Furthermore, you note that it is impossible for your hand to contain two items at the same time. F is the maximum possible score, that is sum of worth of sold items. Given an array of length n, you need to find the summation of L is equals to 1 to n and summation of R is equals to L to n. F A L R, which means we have to find the summation for all the possible ranges, right? And do a modulus with 9 and 8 to 4 for 3 by 3. right? So this problem, we are asking, but I can just reframe this problem as you have a container. It can hold at most one item, and there is an array. So array A will define the cost of the item. So you can add the cost here, and uh, if you want to sustain this array element, like if you don't want to sell it, for each step ahead, the array value will be increased by 1, like this. And you can choose any moment to sell this particular element, so that selling cost will be even plus 2, because you have stored for 2 times. Now you cannot hold any item at the end of the timeline, which means you have to sell at this particular point, right? And you can choose to buy or sell at any time, right? Now you are asked to find summation of L is equals to 1 to n, summation R is equals to L to n, f a L comma R. Or you can define it like this: the loop of L is going from 0 to n, and loop of R is going from L to n, and you are asked to find from AL to AR the cost, maximum cost you can hold. And you have to do addition of all this in your total cost. So anyone who was able to come up with this problem, or got a solution for this, any idea what we can do? Let's first simplify the math. Okay. So say you buy AI on ith day and sold on jth day. So the value you got will be AI plus j minus I, right? I can rewrite it as AI minus I plus j, the value. Now, if you see this particular thing, this can be calculated with the leftmost limit, and this can be calculated as the rightmost limit. So for AI minus I and for j, you can define it as this is the buying part and this is the selling part. Okay. So I can reframe it as I need to maximize summation of AI minus I plus j over all distinct buying and selling pair. So I can make one more statement as we need to find the sum of our start points, whichever L. We can't run a loop because it will give us TL. Guess n is 1 5. right? 2e5, 1e5. It is 2e5. So we cannot run a loop on this particular scenario. So what we will do? So we have to process all the starting point, which is L, simultaneously while traversing R, right? Which means if R is fixed, I need to choose all the L which are less than equals to R, and we need to maintain a value VL for this L as the starting point, which is the maximum effective selling point or range, or you can say anything, maximum effective value, right? AI minus I, right? This thing is BL in this particular range. Okay, now this VL will track the profit versus when you don't have anything, which means this VL will track a profit, like it will track AI minus I plus J, and either it can also track when you don't have anything, which means when you don't have anything, that is I minus I, or you can say that your hand is empty. Okay, so to approach this problem, we will use a segment tree for the range updates and range query plus a monotonic DQ. Range updates and queries, and monotonic DQ for maintaining VL. We will make it from max to min, or you can say decreasing value of VL. The DQ will work in decreasing value of DL. Okay, so segment tree will do range update and queries, and it will hold the current total score for every L, and this DQ will maintain the value V for the set of intervals. It will be sorted in the decreasing order. Right. So coming up to the algorithm, what we will particularly do in this problem is we will take a subarray. Let's say a subarray L as starting point is I. So current profit is nothing. So I will take it as negative infinity. So buying will cost AI minus I, right? If I buy this particular ith item, it will cost AI minus I. And for any L where the best buy VL is less than C, or you can say this particular cost, it is better to switch in buying mode, right? Why? Because my currently the value of left, or the value at L, is less than the current cost, and this value L is ai minus I plus j. So this is less than some cost which is coming, let's say ak minus k. So if this is greater than, if I sell it in some index t, then it will also be greater. So it is better for me to update VL with the cost or put in the DQ. I can, my DQ is in max to min format. So if VL in this, VL is in the start and there are other B's, so I will append my cost in the front. So yeah, and the lowest values are at the end, and the maximum value is in the front. Right. Now this was the buying part. What about selling? So selling is profitable if our this value VL plus the particular index is greater than 0, or you can state that VL should be greater than negative I. And as I just said that DQ is in this sorted order from maximum to minimum. The maximum VLs will be in the front of DQ. These will give us maximum VLs. So we will just pop from front and say VL plus I as my profit, right? And I will send this to the segment tree to update the cost, right? And then reset to -1, minus I, sorry, reset to minus I, because we have sold the profit, so we are currently as empty-handed. So now, while coming to the code, I need to make sure that you need to be aware about segment tree, range propagation, and lazy transformation, because we will be updating the segment tree also in the runtime. Okay, and you have to aware about how DQs work, monotonic DQs, about pop front and pop back. After that, we can move towards the code. Okay, so let's see the code. What we are doing here. As you can see, I have made a segment tree. There are two arrays, tree and lazy. As I have defined, we are doing the lazy propagation also. So tree is for the segment tree and lazy for the storing of the value for future updates. This is push function in which I am pushing the node in the start and end. So if lazy node is true, I will push tree node as tree node plus lazy node multiply by the length of the segment, right? Multiply by mod. If start is not equals to end, then you have to update for both the children, lazy 2 into node and lazy 2 into node plus 1, which will be just addition of the both with the lazy node, right? And set lazy node as 0 because you have updated your lazy node, or the tree. You have updated your tree, then lazy node will be deleted. I am not going to explain this part because segment you must be clear about segment trees, lazy propagation, then you can understand it very clearly. Then about the update, I update for the node start and LNR and the value. I just post the node into the lazy, and if it is invalid, then you can just return. If it is in the range, you can just update directly as lazy is equals to lazy plus val and push it inside the lazy again, and take the mid and update your both the children LNR, and then you can update the final tree as summation of both the children. Then I have done a query when you are querying, you have to just first push the node in the lazy, and if it is invalid, you can return 0. If it is in the range, you can just return tree node, and then you can take mid is equals to start plus n by 2, and this then query both of the children and just add and return. Okay, so this was the segment tree part. I hope you are able to get it because it was the basic segment tree. I have not done anything very uh, it is the basic addition segment tree. I have not done any complex thing or rocket science thing. So the node is, I have defined a node as in the three value as L, R, and B, which we have talked about. B was that current value, BL. So here I have taken T as input, while T minus N is I have taken N as input and array as input. I have defined my segment tree and DQ, and the total answer is the sum of all the summation of these L, R, F, A, L, R. Sorry. So I have iterated from 1 to n, and I have pushed my q from the backward with the least possible value, which is negative infinity. Now my cost of the current index is ai minus I, and the leftmost cost will be uh, I plus 1. So I can sell at I plus 1 also. So the selling cost will be I plus 1. Now if q is empty or q dot back is less than c, which we have talked about, if the value at the back of the q is less than c, we can just update our we can take out the leftmost value, and uh, we can do a pop operation for the q. So the leftmost value is deleted. Then, if the leftmost index is less than equals to I, this is the selling point. Then you can push the queue with the new cost. And here I have done a second selling of selling. Sorry, this was the buying part, and this now we are starting with the selling part. So our currently sell part is minus I because we have not holding anything. Now the rightmost is 0. So you can say that we have not sold yet. Now again, if q is empty or q dot front, because front has the maximum amount of value, which has the maximum value. So if it is greater than d, I can just assign my node as q dot front, which will contain all three values as L, R, N value. Then I update my segment tree with this particular value because it is greater than the current cost I am selling. So the current cost I am selling is greater than the front. So I can just update my segment tree, and my leftmost value will be rightmost value will be updated as R. If rightmost value is greater than equals to 1, then you can also again push, which means the you are not currently standing at the first element, you are standing at all the elements after 1, which is 2, 3, 4, 5, 6 up to n. So you can again push into the queue from the front because it is the maximum value, and you can add in your answer as a answer plus segment tree dot query from 1 to n, and you do a modulus n. So after this, you will get your answer. So is this clear? Any doubt in this particular problem? Anyone, any doubt? If you don't have a doubt, we can wrap up today's session. Okay, guys. Thank you for joining. I hope you were able to understand each and every problem clearly. And if you have any doubt, you can just comment it. I will look at the comments and try to provide you a solution as soon as possible.